Hi folks, so this is extending the life of layer 3 switches in a 256,000 and more route world as a throwback to, I don't know how many of you have crashed the Herbalife party last night that was downstairs from the brewery, the lose weight now, ask me how. Well, this is lose routes now, ask me how. And you're welcome to ask me, and as Bill said, I do work for a consultancy firm, so I can answer your question, and I'll even like to take money from you answering your question if you want to give it to me. This is we've talked about this many times. It's a very common thing. I just want to give you some real world experience, some feedback on stuff that we've actually deployed and how it's performed. So problem really simple, a few layer 3 switches. I'm not dogging on Cisco, just what we have most the experience with, so I'm just mentioning a couple very common Cisco platforms, SOUP to MSFC2, 256,000 routes, SOUP 723B, either 192 by default or 239 if you repartition the TCAM, and of course do a reboot. Public internet routing table now is 263,000 routes, approximately, probably greater than, let's not fight on that. And of course that just doesn't work at all. I don't know how many of you have actually experienced what happens to some devices when their forwarding tables get overrun, but it usually isn't a good result, and it's not something that you want to show up on your annual review. So I'm targeting here enterprise data center network operators who have older equipment in there. I'm not talking to you if you're providing BGP to your customers. You really want, at that point in time, you want to be able to hold the full table and share the full table with your customer base. This is for enterprise data center networks that maybe are multi-homed to multiple ISPs, and you're taking a full BGP feed either because you want it for better traffic engineering, so you want to send this AS here and that AS there, or you're collecting data such as S-flow, NetFlow, and you want to gather metrics, how much data going to this AS, this transit AS, this penultimate AS, and so you really want that full table in there as much as possible. But you find yourself constrained by either funds, power, rack space, just time, human resources, network engineers to go out and make your devices happy for 263, 300, 320, more than 320,000 routes in the forwarding table. Ideal solution, my opinion, I think some other people are of this opinion, why do we need so many routes in the forwarding table? Especially, again, not an ISP's network. This is the enterprise multi-home, this is the data center multi-homed. There's not that many next hops, so why do I need the whole table? Why can't my router software simply do some aggregation and say, well, you know, this aggregatable chunk of address space is all going out this one ISP link, that's one forwarding table in your TCAM. You know, maybe the vendors don't want to do the software because they want to sell the hardware and it's quicker. That's one conspiracy theory. There are lots of other reasons why, but the point is it doesn't work right now that way. Unless, if it does, somebody tell me, and I'll start pitching that gear. The current solution is you buy new hardware. Sometimes you just, really simple, you pull out the old management module, you put in the new management module if you're doing centralized forwarding. Sometimes you got to upgrade every single line card in your chassis if you're doing distributed forwarding. Sometimes, and this is, again, real world that we've run into, yeah, you can replace the management module, but all those management modules fit in different slots in the chassis. Oh, and you need higher speed fan cards. Oh, and you have to go to 208 volt because you need more wattage, and you got to swap out your power supplies too. And you know that fan card is actually blocked by a whole bunch of Ethernet cables, and you can't just swap it out without unplugging half of your cables. So we run into these problems. Is there an acceptable workaround? Something to buy you time. This is not a permanent fix, but can we buy you some time? It's got to be quick. It's got to be easy. It's got to be inexpensive. You need to retain as much relevant routing information in your table as possible, because again, you want it for traffic engineering statistics. And you need to maintain what I call routing accuracy. So the short answer, you've got to abbreviate the routing table, prune your BGP routes. What's routing accuracy? What I define as routing accuracy is how much traffic we can still forward without following the default route. Anything that can't follow a shorter match and it goes out the default, that's considered inaccurate. It's not the end of the world for you. It's not going to harm your end users because it's going to go to your upstream ISPs, and your upstream ISPs, of course, can carry the full table, and they'll know how to deliver that traffic. So how is it done? If you want to do this, the very first thing you must do is make sure all of your ISPs, in addition to the full table, are setting you default, because there will be some traffic that you will no longer have in your forwarding table, and you don't want to disrupt those people. Make sure it's not just one ISP, please. All of your ISPs send you default so that when that one ISP goes down, you don't wonder how come you're getting additional calls from end users saying, oh, I can't, this cable modem provider can't get to your server. And then you just throw away some of the long prefixes and you check your results. You check how much did I reduce my routing table by, am I happy with it, and how accurate is my network. How much of your network can actually follow your forwarding table without going to quad zero. If you want some ideas on how to do this, ask me how, and I'll give you some pointers. We had a goal to try to achieve over 90% routing accuracy. My personal goal was 99% routing accuracy, and still allow the networks to run efficiently with their legacy hardware. So this is the filter I did. Pretty simple. 91/8, just because 91/8 is kind of a curious block that was allocated, according to documentation, was allocated up to /29. Me personally, I'm happy rounding /24s on the public internet. So for that block, I did allow up to /24. For the classful A and B legacy space, so from first octet from 0 all the way to 191, I'm going to allow up to and including /23s. So I'm just throwing away some /24s there. For everything else, the historical class C swamp space, I'm just going to allow up to /24. And see what happened. So when this was done, first time we did this was in May of June of 2008. Not the first time, that's when we actually did this. We had a couple networks which were at 253,000 routes saying, whoa, we're going to fall over any day. So we managed to reduce them from 253 to 199,000, which fit very, very nicely, gave them some breathing room. Looking past into September, those same networks are now sitting at 205,000 routes. Again, pretty healthy. And by them, I don't know if they're going to have a month, 2 months, 7 months, maybe 10 months before they need to really make sure they get those new devices in there. As far as accuracy, in these cases, on 3 different networks, we're able to maintain better than 99% accuracy. So it means that on a network running 1.5 gigabit per second at peak time, their default route was only transiting 9 megabit per second of their network, 300 meg peak, 450 kilobit. And the largest network I did this on was a 5 gigabit per second network at peak time. Less than 30 megabit per second actually followed the default route, meaning those 54,000 routes we threw away were not very relevant to that network. A few tips. What we tried to do here is apply a few broad strokes and then just get back to other work. First of all, we bill by the hour, and we didn't want to. The client really didn't want to spend 100 hours having us fine-tune the table. But at the same time, if I can do a few broad stroke changes and fix the problems, I can go on and do something more interesting. Because we know that at the end of it all, they're going to have to buy some more hardware eventually, or they're going to have to spend the time and actually implement it. Don't dwell on minimum allocations. There were a couple examples in the NANOG threads and the archives, a few very, very smart people giving very good advice. Where they're building pretty complex prefix filter sets based on minimal allocations. It just seemed like a lot of work. It seemed like you were maybe throwing a little too much that was relevant away, maybe keeping a little too much that just isn't necessary. Basically finding diminishing margin of return. So you can spend days and days and days tweaking your route table. What will happen is you're going to reduce your forwarding table size, that's true. You're definitely going to significantly reduce your accuracy. As well, and if that was a goal of yours, why do it? So anyway, broad strokes, go make a VLAN change or ACL change or a 10 nanog or something. Wow, and there's the question slide. I actually pulled out another slide. Just so you know, these are getting posted, right? So I'm not going to show you now, but if you download the presentation, I threw a couple references. The actual configuration, I actually gave it to you, and a couple additional results. Showing diminishing margin, and if you're really curious where the minimum allocations are. So you can download the PDF and view them there.
All right, time for 1 or 2 questions. Anybody have anything?
You all like it. That's good.
Is that Rob heading for the mic?
Hi, Rob Seastrom. Can you flip back to the slide that has the characterization of packets that were following all counts on those?
The accuracy one, this one?
Yeah.
Okay.
So I'm sort of not following the last one there, but for the smaller flows, did you do anything in terms of analyzing those and trying to figure out whether the traffic you actually cared about and whether it was backscatter from that stuff that was floating in through the transit?
Yes, so I actually did through some packet sniffer following the default path. Take a look at what it was, and it was real end user traffic, and then I just I just took a sample, a mental sample, a visual human sample of some of the destination IPs and looked back in the routing table and said, sure enough, these are, for the most part, they were broadband providers that were doing /24s and not announcing an aggregate, a DAG as well. Sorry, not announcing the aggregate as well, they're just announcing a whole splattering of /24s. But it was all valid end user traffic. Yeah.
All right, well, that's it for the questions. Thank you very much, Danny.
Okay.
And,
Thank you very much.
and